You know how we always talk about light being both a wave and a particle? Well, this new research is making me rethink everything I thought I knew about photons.
Oh,
Yeah, get this. Scientists at the University of Birmingham just published this paper, Quantum Leap. Scientists reveal the shape of a single photon for the first time. And they say they've actually, visualized the shape of a single photon.
wow, that's a pretty bold claim.
Yeah.
What makes this research so groundbreaking?
Well, from what I understand, they've tackled a problem that has stumped physicists for, decades.
I can imagine. Modeling how light interacts with its surroundings at the quantum level. That's got to be incredibly complex.
Right. It's like the article even says it's like trying to track every single ripple in a pond during a downpour. Just like
Yeah.
an insane number of variables to consider.
And how did they manage to crack it? The article mentioned something about grouping these interactions into sets, right?
Yeah, that's what really caught my eye. For years, it seemed like the sheer number of possibilities made it impossible to build a really accurate model.
So what did they do differently?
Well, it sounds like the Birmingham team found a way to simplify these interactions by almost like creating a sort of periodic table of how light can behave.
Interesting. So they're not just looking at the photon itself, but also how it's affected by everything around it.
Exactly. They're considering the nanophotonic environment. Think of it as this meticulously designed structure at the nanoscale, like engineered to interact with light in very specific ways.
So it's like building a tiny, intricate maze for photons, and they're mapping out every possible path the light can take.
That's a great analogy. And by doing that, they were able to predict, wait for it, the shape of the photon itself.
Hold on, I need to make sure I'm following this correctly. This new model allowed them to calculate how a photon interacts with the emitter, but also how that energy travels outward.
Yes, what they call the far field.
Okay, I see. And what's really remarkable is that these calculations led to an actual image, a visualization of the photon's shape.
Right, we can actually see what a single photon looks like now. It's mind-blowing.
And it's not just some blurry blob either, right?
No. The image shows the photon as this localized concentration of energy and its shape, directly influenced by that nanophotonic environment we were talking about.
So it's not like a billiard ball with a fixed shape. It's more like the environment molds the photon as it's emitted.
Exactly. And one of the researchers, Dr. Yuan, he emphasizes this point in the article. The geometry and optical properties of the surroundings are absolutely crucial to understanding how a photon is emitted.
I mean, that makes sense, but how far does that influence really go?
It affects its color, how likely it is to even exist, and yes, its very shape. It's all connected.
That's fascinating. But you know, there's a comment in the article that I found interesting from someone named Oren. They brought up special relativity, saying that because photons travel at the speed of light, they should look like infinitely thin disks to any observer.
Oh, yeah, I saw that comment too.
So how can we even talk about them having a shape?
That's a really good point. And Dr. Yuan addressed this in his response, explaining that while the leading edge of the wave packet, that initial burst of energy, is indeed incredibly thin,
Right.
there are also these higher order interactions at play.
Higher order interactions, what does that even mean?
So imagine dropping a pebble into a perfectly still pond. You get that initial splash, the sharp wave front, but then you have all those ripples and secondary waves that continue to spread outwards.
Okay, I'm starting to see where you're going with this. So it's not just about that first instant. It's a whole cascade of effects that continue to shape the photon over time.
Exactly. And it's these more slowly evolving effects, heavily influenced by the nanophotonic environment, that contribute to that localized shape we're able to visualize.
Wow, this is really making me rethink everything I thought I knew about light.
Yeah.
It's incredible how something so fundamental can have such far-reaching implications. It really is amazing. And the implications are huge. Like, think about secure communication.
Yeah, okay. Secure communication. Right now, it relies on these super complex algorithms, but even those can be cracked, right?
Exactly. With enough computing power, any code can be broken.
And that's where this whole quantum entanglement thing comes in.
You got it.
I've read about it, but honestly, it always seemed kind of like science fiction to me.
I know, it does sound pretty wild, but it's a real phenomenon.
So just to remind me, what is entanglement again?
So entanglement is this link between two particles, no matter how far apart they are. If you change one, the other changes instantly.
Whoa, okay. And we could use that to encode information onto these entangled photons.
Exactly. It's like having this secret code,
Yeah.
that only you and the person you're talking to know.
Okay.
And if someone tries to intercept that message, they disrupt the entanglement.
Oh.
And that alerts both the sender and the receiver that something's wrong. boom, unbreakable encryption.
So we're talking about a future where hacking and data breaches are a thing of the past.
It's definitely a possibility.
That's amazing. Okay, what about other applications? I remember the article mentioned pathogen detection.
Oh yeah, that's another exciting area. Imagine sensors that are so sensitive that they can detect a single virus or bacteria particle.
Hold on, so not just like a bunch of the virus, but like one single particle.
Yep, we could diagnose diseases super early, even before any symptoms show up.
No more waiting for test results. That would be incredible. We'd know instantly if we were dealing with a dangerous pathogen.
And think about it.
Right.
This tech could be used for food safety too, making sure what we eat is free from all these nasty contaminants.
Yeah. Preventing outbreaks before they even start. It's like, is there anything this research can't do?
Well, we haven't quite figured out how to teleport people yet, but
Okay, fair enough.
But I do want to mention one more application. This one is kind of science fiction-y. Controlling chemical reactions at the molecular level.
Wait, what? How is that even possible?
Remember those tiny Lego bricks we were talking about earlier?
Yeah.
By understanding how photons interact with matter, we can basically use light as a tool to manipulate those molecules with, like, incredible precision.
So, like, shining a special light on a bunch of molecules and making them rearrange themselves into a specific shape. Like, is that what you're saying?
You got it. The potential for fields like medicine is huge. Imagine delivering drugs directly to specific cells using light.
Wow. Minimizing side effects and maximizing their effectiveness.
Exactly.
This is, like, blowing my mind. It feels like we're on the verge of this massive technological revolution.
I think we are. And to think, it all comes back to understanding the shape of a single photon.
It's pretty wild. I do have one more question about that, though. There was another comment in the article that caught my eye, this one from someone named Ralph, and they were wondering about whether the photon shape that was visualized is 2D or 4D. Any thoughts on that?
That's a great question. Well, Dr. Yuen didn't specifically talk about the dimensions of the shape in the article. He did emphasize that the surrounding environment plays a key role in determining that localized shape.
Right.
So it's possible that the dimensionality of the photon shape is more complex than we currently understand.
It's crazy to think that even with this groundbreaking research, there's still so much we don't know.
Totally. And that's what's so exciting about science. This research isn't just about taking a picture of a photon. It's about understanding that fundamental energy exchange between light and matter.
Okay, I see.
And that understanding is going to open up so many possibilities for the future.
So we've talked about secure communication, pathogen detection, manipulating chemical reactions. The article also mentioned something called nanophotonic technologies. Can you break that down for me?
Sure. Nanophotonics is the study and application of light at the nanoscale. We're talking about controlling and manipulating light in ways that we never could before.
So, like, what kind of things are we talking about here?
Well, imagine optical computers that use photons instead of electrons to process information.
Okay.
They would be so much faster and more energy efficient than the computers we use now.
That would change everything. Scientific research, artificial intelligence.
Exactly. And nanophotonics could also lead to breakthroughs in medical imaging, letting us see inside the human body with incredible clarity. We could diagnose diseases earlier and more accurately. We could develop new surgical techniques that are minimally invasive.
It's mind-blowing that all of this is possible because we're understanding the behavior of these tiny particles of light.
It really is. It shows that the biggest breakthroughs can come from the smallest discoveries.
This research truly feels like a quantum leap forward in our understanding of light and its potential.
It definitely is. And you know what? It highlights the incredible power of human curiosity and ingenuity. This research is a reminder that we live in a world full of wonders. The more we explore, the more we realize how much more there is to discover.
This deep dive has been amazing. I'm still processing everything we talked about.
Me too. It really makes you think, what other secrets of the universe are out there just waiting to be uncovered?
That's a great question. What other mysteries are hidden in the quantum world?
Who knows? But I can't wait to find out.
So we've talked about secure communication, pathogen detection, manipulating chemical reactions. The article also mentions something called nanophotonic technologies.
What exactly does that mean, and how does this research tie into it?
Well, nanophotonics is basically the study and application of light at the nanoscale.
Nanoscale.
We're talking like billionths of a meter. And we're talking about controlling and manipulating light in ways that, well, we just couldn't even imagine before.
So, like, are we talking about building tiny lasers here? Or creating optical circuits on a chip? What exactly are we talking
Yeah,
about?
exactly. Things like that. And this new understanding of photon shapes and how they interact, it's crucial for actually advancing these technologies.
Okay, I see.
For example, imagine optical computers
Optical computers.
that use photons instead of electrons to process information.
They'd be so much faster and more energy efficient than our current computers.
Wow. Yeah, that would revolutionize, like, everything. Scientific research, artificial intelligence.
Exactly. And it's not just about computing. Nanophotonics could lead to breakthroughs in medical imaging too, allowing us to see inside the human body with this like crazy level of clarity. We could diagnose diseases way earlier, more accurately, and even develop new surgical techniques that are minimally invasive.
It's really incredible to think that all of this is possible by just, like, understanding the behavior of these tiny particles of light.
It really is. It shows you how the biggest breakthroughs often come from the smallest discoveries.
This research feels like, I don't know, such a huge leap forward, like a quantum leap, even in our understanding of light and its potential.
It is. It is.
Okay.
It really highlights the power of human curiosity and ingenuity. This research is a good reminder that, hey, we live in a world full of wonder, and the more we explore, the more we realize how much more there is out there to discover.
This has been such an awesome deep dive. I'm still wrapping my head around all of it. It really makes you wonder, what other secrets are out there? Like hidden in plain sight, just waiting for us to find them.
Right. It's a great question to think about. What other mysteries are hidden in the quantum world?
Exactly. Well, thanks for joining us today for this incredible journey into the world of quantum physics. And until next time, keep your minds open, stay curious, and never stop exploring the universe and all its mysteries.